Hey guys, Nick here from Test Me Tutoring. We'll just give a couple of minutes till we start off. But yeah, this is the further maths exam 2. It's the revision for that one. So yeah, as I said, we'll just give it a couple of minutes and then we'll start up. All right, we'll get started. So, as I said, I'm Nick from Test Me Tutoring. This is the second further math stream that I've done. The first one you can find on the channel under the videos, if you'd like to go back and have a look. But as I said, I'm doing this just to help out the Year 12s because I know it's a pretty tough time with studying from home and all that, and online learning is obviously really it's quite difficult. So I've been a tutor for 6 years, and yeah, I've seen students have a really difficult time at this with working from home, and yeah, so just doing these streams to help out with some of those difficult concepts. So this is a revision stream for the exam 2 on testmetutoring.com.au, so I'll link that a bit later. And yeah, so you can go, they're free at the moment. I'll be doing the next one for free as well. It's just 40 further maths questions, similar to VCAR exams. I write them myself, and just to give you guys some practice for the upcoming exam, because it's coming pretty soon. So yeah, I'll leave the current one up for another few days, and then the next one will be up later next week, and it's open for a week or so. And in a fortnight's time, so what will that be? That's the 6th of September. We'll be doing another stream, so that will be a stream on the further maths exams 3. So yeah, like us on Facebook, subscribe to our Twitch, or and have a look at the website if you want to stay updated and get notified when we do these streams, as well as the exam. So today we'll be looking at amortization tables. So there was a few questions in the exam actually, because it wasn't on the first exam, so I added a few more amortization questions. And there was one in particular that was a bit, it wasn't answered as well as the other questions, and it was just to do with the wording of the question, but it was purposely worded like that. So we'll go into that a bit later as to what it was. So I'd like to go into amortization, how we build amortization tables, how we can read them, and some calculator work, because in further you can use a calculator on all the exams. So we can also talk about what we should have in our bound books. So the calculator I'm using, it's at the top right of my screen. It's the Casio ClassPad. Now I know a lot of you are using the TI Inspire. This is a very, very similar calculator. It's just, it does the same function. It's just a different format. It's the one I used through Year 12. So I did also graduate in 2013. So it's been a bit since I was in Year 12, but I've been obviously tutoring the entire time, so I've kept up to date. So yeah, happy to get started. We'll get going on amortization. So amortization tables. Now there's basically two types we'll see. There's an amortization table on loans and an amortization tables on investments. Now, loan amortization tables, we want the values to be getting smaller, our balance to be getting smaller because we want to pay off that loan as quickly as possible. Investments, we want our values to be getting larger. So investments like putting money into your bank account, investing in real estate, investing in shares, anything like that. Loans, get a loan for a car, house, anything like that. So both of these, they come with interest and an interest rate. Now that interest rate is calculated, and you'll have to excuse my poor writing at sometimes, but deal with it. So the interest rate is calculated yearly, can be calculated monthly, can be calculated fortnightly, and weekly. Okay. Now, each of these, we have to deal with a formula, right? And the formula is to calculate our, oh, that's not right. That's about R. To calculate our formula, we have to go R equals. So this is useful for finance questions as well as amortization. But to figure out your rate, we can do what our rate is, so the rate in the question, and we have to divide it by whatever our period of compound is. So with yearly, our period, that basically is how many times it compounds every year. So yearly, it only compounds once per year, right? Just one time every year. Monthly, we compound 12 times a year. So every month, it's basically we're getting a portion of that interest every month, okay? Fortnightly, we're compounding 26 times a year. And weekly, we're compounding 52 times a year. Okay? So whatever our rate is in the question, we've got to divide it by our compounding period. So I'll just make that comp, okay? And then we divide all of that by 100. Okay? So I'll give an example, obviously. So let's say we've got 4.8% per annum. So that's per year. But we compound monthly. Right? We have to do 4.8, so our big R is equal to 4.8 divided by, now monthly, this is something we can put in our bound book. Monthly is 12 times, and then we divide all of that by 100. Now, just careful with your calculator because sometimes you can do 12 over 100, specifically the TI Inspire. Sometimes it does some funny things with BODMAS and things like that. So what I like to go is 4.8 divided by 12. Now, if you want, we can use the fraction symbol, but first do that, and now we divide that by 100. So make sure you hit enter first, okay? Now that's for, can I change that to, no, but basically that's 0.004, okay? So that's what that's saying, but we can leave it on the calculator for now. We don't really need that to be written out, but that's basically what we're multiplying our balance by to figure out the interest. Okay, so again, that might seem a bit daunting at first, but we'll write out, that might be the full amortization that we're writing out, but we'll do it manually first. So yeah, just remembering this formula up here. So an example that we can use here is, let's say we've got 2.8% interest rate. And let's compound monthly. And we're repaying, that's an R, and we're repaying $700 per month for this loan for a $30,000 loan. Okay. So there's a lot to take in for this question, and questions are usually quite lengthy for amortization. So there's big things we've got to take into account here. Compounding monthly. Okay. We're paying $700 a month and $30,000 loan, as well as this interest rate. Okay, they're basically our big things. So I'm just going to keep moving that down. It's very bright. So for amortization, the columns in our table are payment number, right? Payment amount, right? Interest, principal reduction. Now, we can say principal change as well. Principal change, reduction. In terms of loan, they mean the same thing, but we'll keep it as reduction for now. And lastly, balance. So these are basically columns of our amortization, okay? Now, payment number 0, 1, 2. We'll just do all up 2 payments. So these are basically, each payment period gets its own line, okay? So the very first one, we're basically saying there's $30,000. That's what we're starting with. So the first column is just, as I said, what period we're up to. So payment number 0, that's where we've actually just gotten the loan. We've just gone to the bank, we've said, can I have $30,000? They've given us the money, okay? So we haven't paid anything yet. We have not paid anything yet. We haven't got any interest on it, and therefore the balance hasn't reduced by anything. We're staying at $30,000, okay? So the payment number 1, how much are we paying back? We're repaying $700 a month, okay? So in the first month, we're paying $700. It's a bad dollar symbol. I'm just gonna write 700. I'm gonna stop with the dollar symbols for now. So $700, okay? We then wanna say, okay, how much interest are we earning? Are we having to owe the bank on our $30,000 loan? So because we've taken money from the bank, they want interest every month. That's how they make their money. So we've got to work out how much interest that is. So as we said before, the formula is, I'll do it down here, big R equals little r over 12, because it's every month and we're dividing it by 100. Okay. So if we have an interest rate of 2.8%, that's 2.8 divided by 12 divided by 100. Okay, so 2.8 divided by 12 divided by 100. Okay, and if we multiply that by our 30,000, oh, that's not 30,000, $70. So that gave us 0.0023. Okay. If we multiply that by our $30,000, that tells us how much interest we're paying. So in that case, we've got $70 of interest, as we saw in our calculator up here. So that's 0.0023 multiplied by our 30,000. That's $70 of interest. So if we think about what's happening, we're paying off, I'm just going to do a small graph here. So we're starting at 30,000. I'll change color. Keep it colorful. We're starting at 30,000. We're paying off that 700, but the bank's charging us $70 to do it. So we've gone back up with that $70. So, and this is kind of what we've got to start thinking about with loans. We're going down by 700, but then we're adding another 70 because the bank's charging us. So we go 700, 700, which we've reduced by, but we've lost $70 of that because that's going back to the bank. So we've only reduced, and this is the important bit, we've only reduced by $630, okay? That's $630 here, okay? What's our balance now? How much has our balance gone down by? We do our $30,000 minus our $630. And that gives us Oh, I did one too many zeros, didn't I? Let's just change that. $29,370 is now what our balance is. Okay. Then we move to the next month. We say, okay, how much are we paying back this month? Paying $700. That's constant. Okay. What's our interest? Our interest is not against $30,000 anymore. Our interest is now against the $29,370. Okay. So again, to work that out, we'll do this whole formula again. We don't really have to, but we'll do it again just to go through it. We go 2.8 divided by 12. And we divide that by 100. And we multiply that by our balance. Okay. $68.53. That's how much interest. And again, we then go our payment, take away how much interest. So $700 minus $68.53. That's $631.47. Okay. That's how much our principal is going down by. Okay. So to work out now what our current balance is, we go 29,370. We take off what we've reduced our principal by. So it's our balance, take away a reduction. $28,738.50. Oh, I'm running out of room. I'll just leave it at that for now. Okay. So that's what we're left with. Right, cool. So what I've got down here is the full amortization table. So this was done in Excel. Usually in questions, you won't be asked to draw 18 rows of this. You might be asked, okay, what would this value, they might not give you this, they might not give you this value here, and you've got to work out what this value, or you might not be given this value here, and you might have to work out that value, okay? So that could be what some questions ask you. Other questions might be asking you, okay, how much have we been charged in interest, or how much has the principal been reduced by after this many months? Things like that, okay? So I think I've got a multiple choice question. So I'll link in chat the poll F. Give me 1 second. So in chat's the poll F. If you just head to that, we'll be going through some multiple choice questions. Okay. So I'll just give you guys a second. Alrighty, so the question is, how much money has been paid into this account? I'll just read the question instead of trying to make my own words. How much money has been paid after 8 months? Okay. So this is, again, one of the questions that it's how it's been worded. So you need to really, you need to understand what it's asking. All right, good. So yes, it's 5,600. Now, as I said, this question, the wording is really important, okay? Because it's not how much has been paid off the loan after 8 months. It's how much has been paid after 8 months. So that is just our $700 every month has been paid, okay? Now, there's a specific wording here. It's not paid off, as I said. So just really be careful, because this was in one of the VCAR exams, okay? Obviously not this exact question, but the style of question where it's saying how much has been paid, okay? So it's our $700, we multiply it by 8. It's as easy as that, okay? Great work. So, if we move to the next question, I'm not sure. Okay, and yeah, this is now, I probably shouldn't have said it. So, this is the next question. How much has been paid off of the loan after 3 months? Okay. Let's have a look. Great work. So again, this is how much has been paid off of the loan after 3 months. So we have our $30,000, which is at where we start the loan, and we look at where we are at 3 months. So we take away our $28,105.59. Oh, and I've not hit zero. Exactly right. $1,894.41. Okay. So I think then we'll keep moving. Okay, so this is, sorry, just one more question on amortization for loans. How much extra interest was paid in the first month compared to the 7th month? So just think about what those columns are telling us. Okay? Yeah, great work. I forgot to lock those responses. But yes, it's right. So to figure this one out, very... as long as we can understand the question, it's quite easy, but it's just understanding what it's actually asking us here. So that's, in the first month, how much interest do we pay? So we paid $70 of interest in that first month. So that's the value just here, okay? Then we look at, okay, how much interest did we pay in the 7th month? Which is down here, that's $61.13. So we take away $61.13. That gives us that $8.87 that we pay, the amount of extra interest that we paid in that first month. Okay? Alrighty. I think, let's leave that for a second. We're going to go now onto the next bit. So any questions? I'll just give you 20 seconds. Just any questions in chat? Alright guys, so we'll now just work, I'll just shift this all down a bit. Oh, that didn't work. Let's move that down. Thought I didn't need this much room, but I do. Alrighty, so we'll just now look at amortization for investment, okay? So investment's a bit different from the loan because, look, our investments are, ideally, they're going up, okay? So instead of our principal being reduced, most of the time, our principal will be increased, okay? Now, there's some specific examples, and these are the challenging ones that I kind of want to go through, where investments will not go up, and we'll talk about that now, okay? So, the question that we can, that I can explain against. We're investing. Oh, I'll just stick with it. That says investing, okay? $25,000 into an account, paying 3.6. Ooh. 20.6% per annum. Compounding fortnightly, actually. Oh, Don't know what it is with the left side of my screen. Can't write. Compounding fortnightly. However, we withdraw. Oh, I'm going to rewrite that because that's not good. We withdraw $200 every fortnight. Now, this is where we really have to understand, one, what the columns mean in the amortization table, as well as what this means for us, like even in real life. Because I mean, this stuff, it's further maths is really good because this is stuff that we could actually use in real life. Okay, so the bank accounts at the moment, obviously the interest rates are not this high, but this stuff we can think about that if we are withdrawing that interest that we're earning every month or so, we could actually have a constant income. Okay, so that's what perpetuities and annuities are like. So we can go over that in a later stream. It's basically what we're doing in amortization. It's just in a couple of different words, but we'll just go now what the amortization table is for investments. Okay, I shouldn't have brought up perpetuity and annuities. So again, I'll write out what the amortization headings are going to be. So we've got payment number, but here we've got withdrawal. Okay, and this is, I'll write it out for now and I'll explain it in a sec. We've got our interest, again, principal change, okay. And lastly, we've got balance. Okay. So I'd like to just, if we look up at what our amortization table was above, we've got a difference in two columns. We've got a difference in what was payment up here. Oh, that you can't really see that on the green. I'll make that red. Well, we've got payment up here. Down here, we've got withdrawal. And up here where we've got principal reduction, we've got principal change. Now, what do those two mean in contrast with each other? Our withdrawal is money we're taking out of the account. Okay, so where payment was, we're reducing we're paying off the loan. Withdrawal, we're taking money out of the account. Now, how do they affect the balance? So, with a loan, our balance reduces when we pay, as we pay, right? With an investment, this is the exact same thing. Our balance reduces as well because we're taking money out of the account. I only say this because a lot of the time they can represent this second column. They can use a few different names. So you just got to understand what's actually happening. Now, a lot of the investment ones are withdrawals, and that's why I've used it as the example here, where even though it's a positive number, where the balance is reducing. Okay, so we'll look into it now. Okay, so, and that's we'll look into it now. Okay, so our payment number 0, again, there's no withdrawals, no interest, principal change, because we've just put the money into the account. So that's $25,000. Okay. Our payment number. Now, again, payment number, withdrawal number, it's basically the first fortnight. What happens in the first fortnight? We withdraw money. Okay, how much are we withdrawing? $200. Okay, again, I'm using the dollar sign. I shouldn't because it's going to take too long. Okay, withdrawing $200. How much interest do we earn? Okay, because in the question, we've got $200 every fortnight. Okay, I'm not going to use a highlighter again. That takes too long. I'm just going to underline things. $200 every fortnight at 3.6% per annum. Okay, so we'll work out what that interest rate is. Again, big R equals, what's our interest rate? 3.6. How often are we compounding? Again, fortnight. If we scroll up, well, we go to our bound book if we need. Fortnightly is 26 because there's 26 fortnights in a year. Okay, 26. And then we divide all of that by 100. Okay, so again, we go 3.6 divided by 26. Then we divide that by 100. Okay, again, it's not a nice number, but that's what we should put in our calculator. I can write it out just so we all know. 0.0138. Again, that's scientific notation. We won't go into it. Just we can leave it on our calculator. And if we multiply that by 25,000, that's how much interest we earn. So that's $34.62. Now, amortization tables. If they say principal change, they are talking about positive means our balance is going to go up, negative, our balance is going to go down. And this is where it all comes down to how we understand the question. Okay? So withdrawing, our balance is going down. Our interest, I'll draw it as a graph again. Ooh. Okay. So we start at 25,000. We withdraw. Our balance goes down because we're taking money out of the account. But because this is an investment, the bank pays us money. So the bank will pay us $34 and it goes back up. So all up, how much are we going down? Okay, the way we work out that is we go $200. Oh, I don't know why I'm going double zero. $200 minus $34.62. So we are going down. Now it's principal change, so we've got to go negative $165.38. Again, the wording of the amortization table will change, and depending on that, well, depending if it's positive or negative. So we've just got to, this is why I'm going through this stuff, because we need to understand this. Okay, we're going down $165. So we go 25,000, take away $165.38. So we have $24,000, $834.62. Okay. I hope that makes sense. Any questions, or are we all right? I'll give you 10 or so seconds. 20 then. Okay, so yeah, good question. So again, our withdrawal, our money is going down. So if we're at 25,000, let's say there's no interest or anything. If we just take out $200, our balance is going to go down to $24,800, right? We've lost $200. So we can think about that as we're going down $200. Okay? But then we get interest. So we have to then add on our interest of, it's $34, not 64. $34.62. And that brings us back up to $24,000. Oh. To $24,834. And 62 cents. Exactly right. Perfect. Yep. So we have negative $200 and we plus $34.62. Oh, I forgot the point there. Exactly right. Okay. Yeah. So again, I'll go to another Polev. Great. So I go to another Polev. I'll just paste it again in chat. Just head there and we'll do a question on investments. Oh, let's go to the next question. So just have a look. I'm presenting. So if you go to that link, will this investment run out of money? Alrighty, let's have a look. Great work. So, I mean, if I was in a tutoring session, I'd say why. So if you just want to just shoot a message in chat, just quickly, I'll give you 20 seconds just to tell me why it's going to run out of money here. Yep, didn't need a question mark there. That's perfect. That's exactly right. Our principal addition is actually negative, so our principal change is negative. So again, principal addition, I've said there, because investments were sometimes worded that they're assuming it's going to go up, but because that's a negative value, we're going down. So we're losing money every time. So we can also call this an annuity, because in the end, it's going to run out. Okay? Now we'll talk, because I mentioned it now twice. I don't have a question on it, but it's very similar to this, what a perpetuity is, okay? So I'm just going to move this down because I think I've got a bit of extra time. So give me a sec. So a perpetuity, because what we just did there is what's called an annuity, okay? It means we've put a whole bunch of money in and we're going to just keep taking some money out. Every fortnight, every month, every year, but we're taking more money out than we're putting in. Okay? What I'll talk through now is what's called a perpetuity. Perpetuity. I always misspell it as well. So, I think it's like that. I forgot the R. There's an R in there. I'm a maths tutor, not an English tutor. So, I'll need a bit more room just to draw the amortization. Okay. So, our perpetuity, just give me one sec. All right, a perpetuity is a really, really good thing to do if you ever win the lottery, okay? And I guess I might use that as an example because it's a healthy way of looking at what we can do if we ever win the lottery. It's a staggeringly high number of people who win the lottery in America, at least, go bankrupt. Yeah, so be smart with your money if you win it. So let's say we win $800,000 winnings in the lottery. Okay. What do we do with the money? So, I mean, I think anyone would probably go buy something they've always wanted. And that's okay. But if we want this money to last, okay, we can put it in what's called a perpetuity. So we find a bank account. So we find a bank account that pays us high interest. High interest of, let's say, 3.1% per annum. And let's say it's paid monthly, okay? Right? Now, I'm not going to write out the entire amortization table for you guys. You're gonna join in on this one. So let's say that's our payment number. This is our withdrawal. This is our interest. This is our principal change. And I hope I've got enough room. That was a really long word. And this is our balance. Okay. I need to bring up my calculator as well. Keep it standard. Okay. So our payment number 0, 1, and 2, let's say. Okay. Now, again, payment number 0, we're putting in, oh geez, 800,000. 1, 2, 3. That's $800,000. Okay. If we want this to be $800,000 the next month, okay, That's the point of a perpetuity. Every single month we can take out money, but the balance at the end of the month has to be $800,000. Okay? What is our principal change going to be? And I'll give you a couple of seconds to respond in chat. What is our change going to be? Yeah, perfect. Be confident. It's okay to be wrong. That's why we're doing these. So leave out the question marks when you answer a question. But perfect. We want our principal change to be 0. Okay? Now, that $0 principal change means that every single year, it's going to be 0. Okay? Every single month, sorry, it's going to be 0. So if we were to graph this, I'm going to just write 800K up here. We get interest. Then we take that interest out. Then we get interest. We take that interest out. Get interest, take our interest out. We're staying constant at this $800,000 line, okay? This is the smart thing to do with a lot of money, okay? How much can we withdraw though? Every month, okay? So I'll give you, again, this one might take a bit longer than the $0 one. So I'll give you a few, I'm just gonna move this down a bit. How much can we take out every month? So I think my mic's been muted for a bit actually, which is, yeah, not good. So, oh geez. So I don't know how long that's been muted for. It must have muted accidentally. All right. So let's just quickly go over this again. So we've got $800,000 and we're withdrawing $2,066 every month. And we're getting that in interest every month. Okay? So that's leaving us at that $800,000 mark. Okay? So as long as we can keep that up every month, we're constantly, and I've left a 0 off there, haven't I? $800,000. Every single month we're staying the exact same. Okay? So that's what's called a perpetuity. And it's something we should do with our lottery winnings if we ever win it, okay? So, because we can keep constant with our money. Alrighty? All right. So I hope my mic wasn't muted for too long. Yeah. All right. Let's hope. Okay. Are there any questions on perpetuities, annuities, or any amortization things? It's been 45 minutes, so we'll have just a quick, minute break. Just get up and stretch. It's always healthy to do it anytime you're studying or working or sitting at a desk, playing games, anything. Scrolling Instagram. Just get up and move a bit. Okay? Also, the next thing we'll be going through is finance. So a question as well, it wasn't answered as well as all the other questions, was something on simple interest. Now, it seems simple interest, obviously, it's the easier of the two, but compound and simple, but there are questions that are asked that it's a bit confusing. So we'll go over that in another, let's say another 30 seconds to a minute. And please feel free to continue chatting. It's great. Alrighty. And I realize why my writing's not great today. My hand's shaking a bit. It's very cold in Melbourne. I don't know where everyone else is in the world or Australia, because I found out this week that there's some people who do VCE overseas, which is in international schools. So if you're listening from overseas, it is very cold in Melbourne. So, alrighty. Let's continue. So finance questions. Now this here was the question that on the exam that a lot of people had issues with. Okay, so we have to look at simple interest. We've got to understand simple interest, and once we do, then we can start solving questions like this. Okay, so let's look at simple interest and how we can calculate it and what it is. So it's not used much. Simple interest is not used much in anywhere, actually, purely because it doesn't benefit anyone. So a lot of loans, investments, anything, we use compound interest because it benefits the consumer. Some loans might try and sneak in simple interest into their loans if they're not as secure as like a bank or something like that, but most loans are compound interest. Okay, so I'll stop talking now. I'll start writing. So simple interest is if I have, let's say, $30,000 in a bank account. Okay, and we want to put so we put it in a bank account and we're earning, I don't know, 2.5% per annum. That's what they say to us at the start with simple interest. Now, this is sometimes questions are worded really poorly like this. Okay. What is this actually telling us? It's saying that with $30,000 for the very first year, we'll earn 2.5%. But every year after that, we're still only going to earn the exact same amount of interest. It no longer calculates to the next figure. So how does that look? Don't worry, I'll go through an example because I don't know if that came out right. If we've got $30,000 and we want to work out what our rate is. So that's our big R equals little r over, what is our compounding period? It's 1 because we're doing it yearly, over 100. 2.5 over 1 over 100. 2.5 over 1 over 100. Now, we can also add 1 here if we want, but I'll explain that in a sec. So if we multiply this number by our 30,000, that gives us $750 in interest. So our interest is our balance or our principal, balance, anything you want. So our principal multiplied by our rate. Now that's $30,000 multiplied by 0.025, because that's what this is. Okay, $750. So after the first year, we had $750, and we're now at $30,000, $750. Now, with simple interest, the reason it says simple in the name is because the next year we earn $750, and that becomes, what's that? It's 30. I'll do it on the calculator just so everyone knows. 31,500. Okay. The next year we add $750, and so on and so on and so on. That differs from compound, that we'll go over in a bit, but at the moment we'll just stick with simple because I want to go through this question here up the top. Basically, every single year we're only earning $750. No matter how much we put into the account, we earn $750 in interest a year. Okay? It's not fair, it's not right, and if anyone ever offers you simple interest, turn it down. So the question that we want to be answering is up here. Now I'll move it down just so we can see it down here. $13,000 is invested into a bank account with simple interest of $255 a year. So it's already worked it out for us. So $13,000 invested, and we've already worked out $255 per year. Now, if I just asked you, it's not what this question's saying, but if I just asked you here, what is the interest rate for the first year? How would we work that out? We would say our $13,000 is what our principal is, and we have to multiply it by our rate. That gives us our interest rate. No, it doesn't. I take that back. That gives us our interest dollars. Sorry. We can use the similar formula, but rearranged. So we go our interest that we earned. I can show you how we can rearrange the formula actually if you want. Divided by our principal. Okay? And that gives us our rate. Okay? So that might have been confusing how I got to that. So I'll do it the formula way. I know a lot of people aren't huge fans of formulas, but I'll still do it that way just in case. So the formula we used before was principal multiplied by our rate gives us our interest. Okay. Now, if we divide both sides by our principal, I'm going to use a different color because I've already used red. Hang on a sec. If we divide both sides by our principal, we've rearranged the formula now so we can crossed out too much. If we cross out both principals, we're left with our rate is equal to our interest divided by our principal. Okay? Now they're the same formula, okay? So what we do here is we go $255 divided by $13,000. And what does that give us? $255 divided by $13,000. That gives us our rate in decimals. So what do we have to do, guys? Multiply it by 100 to change from decimal to percentage. 1.9615%. Now, that was one of the answers to the multiple choice, okay? But this is in the first year. Okay? What's going to change in the fourth year? Is the interest going to change? No. The interest is going to stay the exact same because it's simple interest. But is our principal going to change in the fourth year? What's our balance in the fourth year? So we have to go $255 again, because that's what we're earning in interest. But how much money will be in the account? We have to go $255 times 4, because we've had, times 3. Take that back. Because that's how much money we've earned up to the fourth year, okay? So if I draw that out, that's going to be $13,000. We're going to plus 255. That's going to be $13,000, 255. I'm going to add another 255 because the second year. So that's going to be 13,255 plus 255. $13,000, 510. So that's the second year. So that's the first, second payment. Sorry. We're going to add one more. We're now sitting at $13,000, 765. Does that make sense? Hope it does. Plus 255. So that's where we're sitting now, okay? So basically, it's a good question. So this is where we start. That's our 0 month. We've just started. This is what we're sitting at our first month. This is what we're sitting at our second month. This is what we're sitting at our third month. This is now what we calculate the interest against. Okay? So for the fourth month, we calculate against the third. Does that make sense? Remember, this is a specific question. It's called equivalent interest rate. Okay? So, and this is one of the confusing questions for simple interest. This is where it gets confusing because as soon as you see the equivalent interest rate, we're saying, okay, against the third month, it's not against the first anymore. The very first principal. It's against what we're at in the third. Okay? So, 13,765. No, so our principal is $13,000 in the first month. Does that make sense? Yeah? Okay. I hope it is because you haven't said anything in chat. So $255 divided by 13,765 multiplied by 100. Oh, I think I've left something. Yeah, I've added one too many 5s up here. Multiplied by 100. I did that very quickly. Let me know if you need me to slow down. Our interest rate is 1.8525%. Now this, again, this is a question that wasn't answered great, but it was in a VCAR exam. A very, very similar question, an equivalent interest rate for simple interest. So if you need me to explain it again, I'm happy to. Just let me know, okay? Give you another 20 seconds. Alrighty, so I assume we're all good, but yeah, again, I'll reiterate because I was just thinking about how I explained it. So the question is stated, what is the equivalent interest rate of the fourth interest payment? Okay, so it's saying all we care about is at the fourth. We're at the third month here, so we're at $13,765. We're earning interest on that of $255. We know that because it's simple interest. What is that rate between these two things? Okay, so $255 divided by that 13,765, times it by 100, and that gives us what our equivalent interest rate is, okay? Hope that's okay. All right, so I think I've got a question against that. Let's have a look. Probably should have written MCQ. Yeah, okay, here we go. But this is a harder question, so hope you guys go all right with this one. And a lot of the answers are very, very similar. So I'll give you guys a bit of time. Move it off here. So we've got to think about it again. Hope I haven't got any responses yet for this, so I'm assuming people are still working it out. So remember, this is a loan, okay? So when we get charged a rate of $280 in simple interest, what's happening to that loan? Is it going up or is it going down? Okay, I'm assuming people are working out, so I'll help you out. It's going up, okay? That loan, money's getting added onto that loan because we're borrowing money from the bank, right? All right, we'll get moving in. I'll give you guys another 30 seconds. Oh, I don't. And I'm just working it out on a second screen because I thought I changed that to fourth interest charge. Okay, I think these answers might not be correct, which is not great. Hang on a sec. Yep, I don't think these answers are correct, guys. So maybe that's why you guys are taking so long. Not taking so long, it's a bad thing, but I don't think these answers are right. So I might skip these questions, sorry. So I'll work it out on the, I'll work it out over here. So let's have a look. So we've got $54,000. And after the first month, it's $280. We're adding $280, right? And that gives us to $54,280. We're adding another one, and I'm going to move these down. Okay. And after the second one, we're adding 280. That's $54,560. Okay. So I'll bring my calculator back over and do that if you need. Okay. $54,000 plus, one, two little zeros, plus 280 plus 280. 560. Okay. Now, we're now looking at what's happening on our third interest charge. So $280 here, we're adding. So we do $280 over $54,000, 560. And we multiply that by 100 because we want the rate. Okay. So we go $280 divided by 54,560. And we multiply that by 100. And we get a rate of Did I leave a 0 off? No, 0.5132%. Okay. So, sorry guys, about that multiple choice question. I think I must have just made a mistake in calculating it last night. It's all good. All right, let's keep going. So again, have a quick break before we look at how we're doing for time. Yeah, we'll go through compound interest. Seasonal indices won't take too long. So we'll just go through what a recurrence relation looks like, because there's a specific question I want to have a look at. Both of these shouldn't take too long. We'll try and finish up around 120. Okay, 120, 130 gives us 15, 20 minutes extra for some questions if we need. Alrighty, let's keep going. And is it? No, so we've got to look at that rounding. Okay. Just in chat, 0.5132. It's all good though. Let's keep going. So compound interest. So compound interest, let's say our V, we're looking at this one in terms of recurrence relation, okay? V0, so that's our principal again. Where we start. A Vn plus 1, again, these are recurrence relations, hope everyone's a bit familiar with these, is our R, which is our rate, multiplied by Vn. Now, these look confusing, they're not overly difficult, so let's have a look. Our V0 is 30,000. Now let's say we have a rate of 3, again, let's just say 3%, okay? Just a rate of 3%. To work out what our R is, very similar to the other one, is R over our compounding period. I'm just gonna write compounding. I think it's T, the letter, but I'll leave it with compounding just in case so I don't confuse you guys. But we add 1, okay? Just for recurrence relations. So we have 3% per annum. So we go 3 divided by, going wide again, divided by 100, and we're adding 1. So that's 3, I've already written 3 divided by 1, dividing it as well by 100, and then we add 1 to that. Make sure you do it in that, because what we want is an answer that says 1.03. We want something above 1 because the interest rate's going up. Our balance is going to go up. So our Vn plus 1 equals, I'll just do what it is up here, 1.03 Vn. Okay. Our Vn plus 1 is 30,000 times by 1.03. So we've now got what our V1 is, which is 30,000. Oh, 30,000 times 1.03. And that's 30,900. Now, if we want to work out V2, we then input our V1 into the formula. So 30,900 times 1.03. Yeah, and that gives us what our V2 value, which is 1.03. 31,827. And if we wanted to work out V3, we would do the same thing, okay? But this is a time-consuming process, because if we wanted to say work out V11, you'd have to go the V3 times 1.03, V4 times 1.03, and that's, no one likes to do that. That will take you a while. So there are tricks on the calculator to do it quicker, but with a compound interest like this, we can use a formula. And the formula is Vn, this is something for the bound book, equals V0, whatever our principal is, multiplied by R, that's that one there, to the power of n, okay? So, the question might be, if we have $30,000 invested, I'm just going to write 30K invested. How much do we have after 10 years? Okay. Again, there's a multiple choice question later, but feel free to work this one out with me. We're using the formula here. And hopefully the multiple choice is right. V10 is equal to, because see how we're going after 10 years? That's V10. V0, which is $30,000, multiplied by our rate, which was 1.03, to the power of 10. So we go $30,000 multiplied by our rate to the power of 10. What we're left with is $40,000, 317. Ooh, 49 cents. Okay. So this is also a really good one if we don't withdraw money. So we're not using those annuities that we were talking about before, perpetuity. We're just leaving it in there. And a lot of parents will do this for their kids when they're really young. But let's say you, as a year 12 student, right? Let's say you had some money saved away, and let's say you had $8,000, okay? You'd been working from year 10, year 9, year 10, year 11, and you have now $8,000. That's great if you do, okay? Let's say we put that into a bank account that gives us 4.2% per annum. And we're 17 years old at the moment. Okay? When we're 40, I won't say we're going to go through a midlife crisis or anything like that, but we want to buy like a Mercedes or something nice. How much money will be in that account? We haven't touched it since then. We put $8,000 away. Okay? And if we go to this, 17-year-old invests $8,000 into a bank account with an interest rate of 4.2%. And sorry, I'll put up the poll ever again. I don't know if I've got new people in chat, but let's put it up. Okay. How much will we have in the account by the time we're 40 if we want to buy a Mercedes? And do you think we've got enough? So I'll give you guys a bit of time. So we haven't got any responses just yet. So I'll go over the formula again that we've got to be using for this one. So remember, it is our Vn equals V0 times R to whatever year we're looking at. Okay. So what's our R in this case? What's our rate, which is 4.2? Okay. And it's only compounding once a year, so it's over 1. All of that over 100 plus 1. And that will give us what our big R is to use in this formula, okay? So I'll give you guys a bit more time. Hopefully that helped. All right, we've got to move on in. I'll give you guys 20 more seconds. Hopefully we get a response. All right, great. We got a response. Alrighty, so let's have a look. We're probably not going to get more responses. Spot on. Great. So just to reiterate, we have got, I'll just move seasonal indices down. We'll go through them quickly at the end. V23. Okay, so that's part of this question. 40 take away 17, which equals 23. That's a 17. Okay. V23 equals a V0, which is $8,000, multiplied by, now, that is 1.042. 1.042 to the power of 23, and that will give us, I think, $20,508. I can do that on the calculator. $8,000 multiplied by 1.042 to the power of 23. Okay. Oh, 608, sorry. That was my memory. Okay. Great. So we'll move on to seasonal. I think that was all I had for that one. Yeah, seasonal indices is next, okay? So what are seasonal indices? Quickly, I'm just going to have a quick stretch. Oh, okay. Seasonal indices. Now, here's an example that I've just written up that why seasonal indices is important. So if commission is, if the more you sell, the more money you earn, okay? So 2 workers that are paid by commission on sales at a surf shop. 1 worker works the winter and 1 worker works the summer. There's going to be a huge difference in sales, isn't there? Because not many people are surfing during winter. So the person who's working summer is going to make more money. So that's where seasonal indices come into it. So if you ever go into business in the future, seasonal indices drive so many decisions about how many people you have working for you, how much you pay those workers, how many customers you expect. Okay. So I mean, even in year 12, I've had to think about, okay, when are people going to be needing exam help? And of course, it's before we're very close to the exam, so it's now. So hopefully you guys understood seasonal indices the first time around, but if not, that's why we're doing this now. So seasonal indices, we represent them usually by a table. I think almost always by a table. Now, it can be days of the week, it can be seasons, it can be months, years. It can be represented a whole different ways, but they're just always called seasonal indices because it's basically saying we can have changes depending on what time of the year it is, okay? And it's called seasons. So I'll do months, for instance, just as an example. Oh, I should not have done that. There's 12 of them. Let's go back to seasons, so there's only 4. Seasons, okay? And down here we've got our index. Rookie mistake here. I drew the table before I knew how many boxes I needed. Okay. So we've got summer, autumn, winter, and spring. I hope you guys know your acronyms, shortenings, contractions. All right. So if we're working a surf shop, we want basically to say, and I'll just write this over here, deseasonalized equals. I do not have enough room. Hang on a sec. Let's just slice through this, and we're going to move this down here. Okay, deseasonalized equals our seasonalized value divided by our index. Right? Now, I even get confused with these a lot of the time. So let's work through an example. Now, if our summer had a index of 1.8 because we're at a surf shop, our seasonalized sales, let's say we wanted to work out what the deseasonalized number for summer is. If we sold $5,000 during summer, we divide that by our index, which is 1.8. What is our deseasonalized figure? So one that if we remove the seasons, what is that? What should have we earned? That's $5,000 divided by 1.8. we should have only earned $22,777.78. Okay, so that's for summer. Okay. Now, in winter, our seasonal index is 0.3. It's not very high, okay, because no one's really surfing. So again, we write our deseasonalized. I'm just going to write deseasonalized is our seasonalized over our index. This time, we've only earned, I don't know, $800 in winter. We divide that by our index of 0.3. So we go 0.8 divided by, oh, no, what is 0.8? 800 divided by 0.3. $2,666. So if I was working in winter and let's say you were working in summer, we've earned, our deseasonalized figures are very, very close together, okay? So, but what that's basically saying is that we are equal salesmen. It's just the time of the year is really causing us to have issue, okay? Just note, I won't go into much detail because we're almost out of time. All of these seasonal indices have to add up to, imagining they were all equal to 1. So 1, 2, 3, 4, all of these down here have to add up to 1. Okay? So we've got 1.8 plus 0.3 is 2.1. And we've basically got 1.9, because if we go 4 minus 2.1, we've got 1.9 to split between autumn and spring. Okay? So just because I can make up whatever I want now, let's say that spring will be 2, and that leaves 0.7 for autumn. Okay? So if we add all these up together, 1.8 plus 0.7 plus 0.3 plus 1.2. It equals 4. Basically, what that's telling us is that we've got 100% total for each season. Now, I don't know if that made sense, but a lot of some questions you'll get are, they won't tell you what winter is. They'll tell you what the other 3 seasons are, and you just need to work out how to figure out the seasonal index. Just imagine there's 1 on each season. That's how much we need it all to add up to. So 1, 2, 3, 4. So then we go 4 take away 1.8, take away 0.7, take away 1.2. That gives us 0.3 for winter. Easy enough? Hope so. All right, let's have a look. We've got a couple more multiple choice. Oh, great. Got a couple of multiple choice questions to do for seasonal indices. That's very bright. I'll put the link. Give it a go. Oops, I forgot to hide the answers. But yes, great work. Let's have a look. Spot on. 4,500. Now, it's great. I purposely didn't go through deseasonalized because I wanted to see how you guys go on rearranging. But we've got the formula again. The deseasonalized sales is sales seasonalized over index. But if instead we're given the deseasonalized value of 7,500 over the index for autumn is 0.6, okay? If we go back, right? We can then work out, where are you, calculator? There you are. We go 7,500 to move the 0.6 onto the other side of the formula. We multiply both sides by 0.6. This is your backtracking stuff that you've learned a while ago, so hopefully it's still in your brain. We multiply by 0.6. That gives us the seasonalized sales of 4,500, okay? Hope that makes sense. All right, let's have a look. I think this is the last question. Very similar. Oops, just dropped something. Sorry guys. Hope that wasn't too loud. All right, we'll probably need to move on. I'll give you 30 more seconds. Great work. Spot on. Yep. Okay. And that's it. That's, oh, gone to the desktop there, sorry. That is our amortization tables, how we build amortization tables with loans, with investments, how we can calculate some of the questions with those, how we look at annuities, how we look at perpetuities, okay? Then we look at our finances. So we look at a simple interest, specifically the difficult question around equivalent interest rate. Okay, I hope that one was okay. It's a really difficult concept. Then we looked at compound interest, specifically around how we calculate things at a set time in the future, instead of having to manually do it every year, year on year. Okay. And then lastly, we just looked at seasonal indices. So that's deseasonalized values. Okay, and seasonalized values. All right. I'll probably hang around for another 10-15 minutes. Feel free to ask me any questions in chat. Now, about maths, I've studied at uni for 6 years. I did a Bachelor of Science and a Bachelor of Engineering at RMIT. Now, I don't know if there's how many people we do have in chat, but if you do have any questions around unis, there's some really difficult decisions coming up for all year 12s. Specifically around which unis to choose, which courses to choose. It's really stressful, and they throw it all in with the exams. Okay, so I'll hang around for a bit. I'll just be watching chat, letting the music run. I'll give you guys 10-15 minutes. Feel free to shoot us any messages. Thanks, and I hope you enjoyed the maths. I'll also put a Google Forms link up. Where is it? Hang on a sec. I'll grab it on my other screen, and I'll grab the Google Forms. Just on a review of how you guys found this tutoring session. If you can, that'd be great. So I'm just attaching the forms in the chat now. Anyone who's watching, if you could just go through and fill out some feedback, that'd be fantastic. Just give you guys some more time. Happy just to chat as well. So I just had a thought, I might as well, just because people might be watching this recording in the future. Just my experience with uni. I went to RMIT in Melbourne, and I chose a Bachelor of Engineering and Bachelor of Science. So engineering was majoring in mechanical, and science was majoring in biotechnology. Okay, so it's a very diverse course in terms of the content. So all up, there was only 4 of us in the whole uni who were actually studying those 2 degrees. So it got a bit lonely at times, but had one friend basically that was in all my classes, but other than that, it was really, we were hopping around a lot. So that's probably the only challenging thing I found really about the entire course, was just dealing with moving around and just meeting new people constantly every single semester. But in terms of the study life at RMIT, it's a fantastic uni. Probably it doesn't have the practical knowledge in the later years of engineering specifically that I would have liked, but there's a whole lot of, they've redone the campus in the city, and it's fantastic, and it's really got that uni vibe that a lot of campus unis have, like La Trobe and Deakin and all those. So it's a fantastic uni to go to. I'd highly recommend it. In terms of, there's a lot of talk. I've been looking at the VCE subreddit quite a lot, just trying to help out. As I said, I'm doing this to help out year 12. So I've been obviously answering questions, and I'm trying to help out year 12s because it is a difficult time. A lot of talk about how unis are sometimes better or worse or everything like that than other unis, specifically Melbourne and Monash. There's a lot of that. These are the best unis to go to, and you need to go to them. It's not like that, and it's really difficult to explain. But Melbourne does have some fantastic lecturers. I'm currently doing a short course at Melbourne Uni at the moment, actually, just on physiology, just to keep myself, just to stay and study and things like that. And Melbourne, they've got some great lecturers, but in the end, it's the same experience. It's the same. You need to push yourself as hard, if not harder, at Melbourne Uni, because the people have that idea that the best people go to Melbourne. So you've got to push yourself, but you have to push yourself at RMIT, at Deakin, at La Trobe, at Swinburne. They're all fantastic unis. So I wouldn't stress too much about trying to go to Melbourne or Monash. Yes, they're great, but these other unis that have a really, really good uni life. So, and in terms of the campus, they're all roughly equal. The campus, Melbourne's got some really old buildings, but RMIT has those brand new buildings as well that I actually prefer. And in terms of social groups and things like that, every single uni has a student union. Every single uni has any social group you want, there will be. It is really a fun experience going to uni, and don't stress too much about trying to find the perfect fit for yourself right away, because personally, I did 6 years of engineering and science, and it's not what I want to do for the rest of my life. And instead of thinking of those 6 years wasted, it's 6 years now that I've come out with a lot of experience. I've got jobs out of it. I've got my problem solving skills, and now I can move into master's courses if I wanted to go back to uni. So I'm considering going back into medicine next year. So don't stress too much. You're extremely young, and trying to get a 17 or 18-year-old to choose what they want to do for the rest of their life, it's all but impossible. A whole lot of my friends coming from high school, everyone's starting to change careers now, and they're talking about people our age. I'm saying our age. Yes, I'm a bit older than you guys, but people our age, you'll be swapping careers very, very often through your life. Because of how fast technology is advancing, you'll be swapping careers quite often. So don't stress too much about trying to find the perfect fit right away. Of course, do something you enjoy. And I think that's the best advice I can give going into it. Go to uni, try and find something you enjoy, because when you enjoy something, you'll do well in it. And then you can make your decisions, because as soon as you do well, the uni understands, yes, you're a good student. So they'll allow you to move to any course you want, no matter the ATAR. And of course, there's caveats with that you need to be doing well. But if you're getting HDs or distinctions, which is your 80% mark, you're allowed to move to wherever you want, okay? So, and as soon as you hit 20 years old, 21 years old, you're a mature age student. So your ATAR, just forget about your ATAR. And you can move around a lot. So yeah, best of luck, guys. As I said, I'll give it 2 or 3 more minutes. Hope that this was helpful for somebody. And yeah, thanks, guys. Good call. I did forget to link that. So we've just got some background music. Oh, I need to actually link it, don't I? Not just a title. So it's just a YouTube playlist. And it actually is a really good point, and I'll quickly talk to that. That I found that this lo-fi music, there's a channel on YouTube, lo-fi hip hop, and it's just this kind of music, this just a beat with a small melody in the background, and it is fantastic for study. Okay, highly recommend it. Try not to listen to music with words while you study. I know and I do it too, everyone does. It's very easy to listen to your music you feel familiar with, but your lo-fi music, it's really good for just switching on and trying to actually focus on. So it's something in the background, because personally I need some music in the background to study well. Highly recommend lo-fi for it. Okay. Yeah. All right. Thanks a lot, guys. I'll stop the stream now. See you later.